Welcome everyone. As Dominic mentioned, Andreas and I, we are working for the Geosphere Austria, so the National Weather Service in Austria. Andreas is sitting in Vienna. I am in Salzburg, in kind of the middle of Austria. And I will start this weather briefing. So some of you might know that I'm a forecaster and I was on shift this weekend. So I would like to present you one day of the weekend, the Sunday, because as you see here with the MSG, Airmass RGB, which I always like to use for getting a general overview over the weather patterns, you see that Sunday was not such a bad day for being a forecaster in Austria, because we were kind of in the middle of two bigger patterns. So we have this frontal system of Eastern Europe. You can see here the cloudiness of the warm front that is slowly approaching. But nonetheless, Sunday was a nice day as this low pressure system over Eastern Europe was heading eastwards. And so, yeah, you see, it kind of looks like a really nice day in the Alpine region. So Airmass RGB always good for a general overview, but for getting more details, we just take a look at the MTG color RGB. You can see here lots of clouds over Eastern Europe, over Western Europe, but over Central Europe, there you have this, kind of small area of more or less cloud-free conditions from Germany to southern Italy. We see here some features which may be low stratus, but let's take a closer look. Because as you can see, thanks to the really magnificent resolution, it's not only low stratus we have here in Central Europe, it's also snow on the Alps. As you can see here, the nice valley structures. With the help of this, you can nicely distinguish between the low stratus over the northern parts of this image and the snow cover on the Alps over here. But in some areas you might not be sure. Okay, here you can see the lakes, so this might also be snow. But what about here? It's a little bit mixed. I mean, this is for sure low stratus, but yeah, what is snow, what not? And for questions like this, we have some other really nice RGBs at hand. For example, the MTG cloud phase RGB, and you can nicely see it here in these bluish colors. You can clearly detect where there is snow on the ground, so on the Alps, as we have already seen before, but also here there is this border of the low stratus, and next to it there's the snow on the ground, and you couldn't really differentiate it in the image before in the geocolor RGB. You can also see some snow here in Italy, Slovenia, Croatia. So yeah, a nice wintry situation that was going on Sunday. But nevertheless, kind of high pressure dominating over here. And now I have a question for you. I have said Sunday was a nice day for a forecaster, or at least for nowcasting on this day. But what do you think was the most remarkable meteorological feature on this day? I have to say that's a kind of nasty question, because you cannot see it, you cannot really see it in this satellite image. So I will give you another few seconds to think about it. So all three options, yeah, are kind of likely. But while you still annotate, you see there's lots of snow in the Alps, and also on the lower lying areas north and south of the Alps. We have a high pressure system over Central Europe. So the night from Saturday to Sunday was really, cloud free, and we also had nearly no wind. So we have three ingredients: snow cover on the ground, cloud-free night, and no winds. And that's the perfect recipe for a really, really cold night, because all of the energy from the soil can, go away into the space. And so it gets really, really cold. So the answer 3 is the correct one. Thanks for taking part in this quiz, and I will show you how cold it got. So here you can see the minimum temperatures from Sunday. I hope you can see here the outline of Austria. I hope you know where we are located. Here is the Alpine Ridge, and you can see this especially in the western parts. So Vorarlberg, Tyrol, and Salzburg, we have really minimum temperatures lower than -10 degrees Celsius. By the way, Salzburg is located here. The city of Salzburg, we had around nearly -9 degrees. And so that you get a better overview, I have also here the list of the top 20 minimum temperatures on this Sunday in Austria. On this list, there were only stations lower than 1,400 meters, so not the high elevated mountain stations. And if there's a cup next to the temperature, that means that a new record was reached. And this was the record for the lowest ever measured temperature in November. You can see here the name of the weather station, and this is the height of the location. So you see it's all kind of alpine stations, mostly, but not all. So I want to point out the 5th place, which is called Liebenau-Gugu with -17.2. So quite cold, but this station is not in the middle of the Alps, but it's over here in the northern parts of Austria. And next to it is the station called Schwarzau im Freiwald. And I have to admit that both of these stations, they were located especially in these areas for measuring these low temperatures, because in this area we have some smooth hills and some depressions on the ground, and in these depressions the cold air really pools. So we have these really thin pools of cold air, and you can get really, really low temperatures in this area. Sometimes, especially during the summer months, it's even colder there than in the Alps, because in the Alps you have all these valley wind systems going on, but not there as in the northern parts, as there are only some smooth hills and not so high mountains as in the Alpine valleys. And what is also very, very interesting, that in this area there was no snow on the ground, so no snow where the stations are located. So if you don't believe me, I have the proof here. The stations are somewhere here, and there's some snow on the higher hills, but not at the location of these surface stations. So that's a really interesting phenomenon that is going on in the so-called Mühl- and Waldviertel, and it gets really, really cold. So imagine what would have happened if there was even snow on the ground. Okay. So I was kind of hoping for an interesting phenomenon to occur, because if it's really, really cold, you can sometimes see it in the satellite images, especially in the Airmass RGB. So if there is really cold air on the ground and a high pressure system, a prolonged high pressure system going on, then you can sometimes see the cold air. I know that sounds a little bit dumb, but it appears greenish. You can see here the recipe of the water vapor, Airmass RGB, and on the green beam you have the brightness temperature difference between the ozone channel and the window channel. And if it's really cold on the ground, then those two channels have nearly the same temperature. And if it's really dry, then you get the biggest contribution from the green beam, and then you can see the cold air in this image. In the situation on Sunday, I think it was probably not dry enough, or the high pressure system was not dominating long enough. It was just the first day of this high pressure dominating the weather. But as the winter is just starting now, if you have really cold situation and high pressure dominating, then take a look at the Airmass RGB, and if you see this color, then it might be due to really, really cold conditions on the ground. But I want to again highlight the snow. We have seen the snow in bluish colors in the cloud face RGB of MTG. Here you can see the snow in greenish colors. We're using the cloud type RGB over here. You have many more possibilities to analyze the clouds. So I would really invite you to take a closer look on the cloud type RGB. I know it seems really complex at the first glance, but it gives you really much information about the clouds and the structures, and yeah. But also you can see something about snow, and snow appears green, but not only green. If you take a closer look at it, you can see that here on the main ridge, so here you can see some yellow structures, some yellow colors. And now I want to ask you, why appears some snow yellowish? Do you think it's because it's a thicker layer of snow, because the snow is drier, or because the atmosphere is drier in this location? So please again use the annotation tools. And okay, snow is drier. The atmosphere is drier. Okay, these questions are really nasty today, I have to admit it. And I also didn't know this. So, but if we take a closer look, here you can see this effect even better. Wait a moment, I still have to, yes. Here, the Western Alps, you can see here over France and Switzerland. You can see here the yellow areas more pronounced. Then you have here the recipe of the MTG cloud type RGB. And on a red beam, you have the near infrared 1.38. And this channel is very sensitive to water vapor absorption. So it strongly absorbs water vapor. So if the atmosphere is really moist, then you can't see some surface features due to that fact. But on the other hand, if the air mass is really dry, then the snow, especially in elevated areas, appears yellowish. So just that you keep that in mind. It does not have to do something with the depth of the snow or the temperature of the snow. It's just, it has to do something with the atmosphere. So wait a minute. Okay, and now we will take a look at the ongoing situation. That's the cloud phase RGB from 9:30 UTC, so quite recently. You can see here lots of clouds over Central and Eastern Europe, only Western Europe, the UK, Ireland, Western France, and the Iberian Peninsula. They already profit from a ridge that is coming in from the west. And here over Central Europe, we have this frontal system of Mediterranean low that is already bringing a new pack of snow to Austria. And yeah, here you have the interpretation of the MTG cloud phase RGB, and I think it's quite easy to memorize that all the bluish colors are ice clouds, and the more pinkish and warmer colors are water clouds. So from this RGB, you also get many details. You can also see snow, as I've mentioned in the beginning, in blue colors, for example, here over southern Norway. But what more can we see, or at least I see it? I don't know whether you see it, but I can see here feature looking like the Grinch over Eastern Europe. And as December is approaching, I thought I would give you a nice outlook how the December might look like. So these are the charts for the weekly mean anomalies of the surface temperatures, and you see lots of red colors, which are not a too good sign for wintry weather conditions, at least not on the surface. Probably some more snow in the mountains, but yeah, especially in the northern parts of Europe, it might be too warm, especially in the first 3 weeks. And then if we'll take a look at the week, at the Christmas week, so to say, we have nearly no specific signal over wide parts of Europe, so we can still hope that some winter wonderland will appear. But now let's take a look on the whole winter, so on December, January, and February. And there's, for Central Europe, I mean, at least from France to, let's say, Poland, there's no real trend, and all the other parts seem to be too warm. And some parts are also really, really much too warm. And if we take a look at the seasonal forecast for the precipitation, there are no significant signals over continental Europe, probably a bit too rainy or too wet over the Atlantic and the Mediterranean Sea. But let's see. I think we will know more than in March. And that's it from my side. If you have questions, then please wait till the end of the presentation. And for the moment, the Grinch and I say thank you for your attention.
So thank you very much, Lili. I take over here. May I present to you? My name is Andreas Wirth. I'm working in Vienna. So yesterday in the morning, I tried to think about what can I show to the weather briefing today. And my topic was from MSG to MTG. So what is the improvements that we really see in the satellite images? And then suddenly, so many images of a volcanic eruption came up that I had to include this topic too. So in the end, what happened? It's a potpourri of different topics. So please don't worry about the different topics. I will try to show all of them to you, even if they don't have really a connection. So the first thing I wanted to show to you is the application of the new channels that we have. You know that MSG and MTG have different channels. Some are the same, some are added. So MSG has 12 spectral channels and MTG has 16 spectral channels. So with MTG, we have 4 more channels. In fact, as you can see here, we have 5 new spectral channels. How does it come? The answer is easy. The high resolution visible channel does not exist anymore. This has been deleted, and now we have 5 new different spectral channels, all of them in the short wave bands. So what can we do with them? We can, for example, detect fires. And here's my first question. Can you see the fire? Where is the fire? Can you annotate it? Everybody can comment it. Yeah, you see it very well. With the higher resolution of MTG, my personal opinion is that fires are quite easy to detect now. They are reddish, yellowish, depending on the temperature, sometimes even white if they are very hot. So, thank you very much. All of you have pointed out the right position. This is the 12 UTC image, but later on we have some other fires in the same area that are visible in the fire RGB. So, but where we have fire, we have also smoke. and the fire RGB is not the best tool to detect smoke. What could we do with MSG? Well, we could use the natural color RGB, and here maybe you can see the smoke of the fire. You cannot see the fire, but you can see the smoke. I allow you to annotate. Just a moment. Yeah, you can annotate the fire, the smoke of the fire if you want. Yeah, exactly. That's it. Well, I just wanted to say very easy to. It's not so easy. So for example, the low clouds north of this smoke also look a little bit the same color. I delete now the comments, and yeah, here it is. And now we have the true color RGB, and you see it's much easier to detect it because we have 3 channels in the shortwave range, in the spectral range of 0.4, 0.5, and 0.6, which is much more sensitive than the channels in MSG. And we can even discern from the color between the low clouds and the smoke. So very good application of the true color RGB. Then on the same day, the 12th November, you can see here Lee clouds over the Biscaya, the Gulf of Biscay, and north of the Pyrenees. In a very interesting color, they are bluish or greenish with a little bit of white. And you may wonder what it is. Let's have a look at the MTG, FCI channels. And I have to say this is again the severe storm RGB. It's not finished tuned, so maybe the colors will change a little bit because the tuning has not been finished for this RGB. But in fact, you can already see that these colors are very similar for these Lee clouds. So the question to you is, what is it? Is it ice clouds, warm water clouds, or are these super cooled water clouds, so cold water? So again, please tell me your preferences and annotate it. What would you say is it? It's Lee cloudiness. So super cool, yes. Okay, I see many experts here. Yes, okay, yeah, sure. You're right. This is still liquid, but cold and not frozen. So how can we check that with the MSG images? Well, we can go here to the day microphysics and check with the color table what kind of clouds we see here. And then we have, maybe it's greenish, yes, greenish yellowish. Maybe it's semi-transparent ice clouds, or it's low to mid-level thick water clouds. In my opinion, they have very similar greenish colors. So, well, the day microphysics from MSG is maybe not the best for this type of clouds. It doesn't really help us. So what can we do? We can do the natural color RGB, and this is also sensitive to the cloud phase. You see the greenish turquoise, cyan, sorry, clouds. These are clearly ice clouds. And if it's whitish, like here, the low clouds over Portugal and Spain, Western Spain, then it's water clouds. So here you see clearly it's rather whitish, so it must be water clouds. What is FCI saying? So here we have the cloud phase RGB. And the cloud phase RGB, as Lili just told us, can separate between ice and water. And if it's the warm colors, like this reddish and whitish colors, then it's water. And if it's bluish, then it's ice. So here we are in the water, and together with the severe storm RGB, which shows the greenish color, we see that it's really super cooled water clouds. So I had another example that I canceled because I had too many slides. So let's progress to another topic that I wanted to include to to this weather briefing, and this is, I don't know if you have heard of it, FINA. It was a category 3 cyclone, and for some parts it was already also a category 4 cyclone, which went along the northern coast of Australia. The damage was mainly due to the wind, not so much because of the rain, but it was in the papers, and I was looking for nice images. Here the Himawari image that nicely depicts this cyclone over northern Australia. Here's the track. So most of the time it was off the coast of Australia, so not doing too much damage. However, the coasts of Northern Territories was affected, and there were also some damages. So 22 November, it had category 3, and then 23, it moved to category 4, and later on, again, back to category 4. So it never reached category 5, which is a very severe storm. It just remained to category 3 and 4. Let's take again here the cloud phase RGB, and let's have a look at the vertical pattern of this storm. And you clearly see here that the top of the cloud is again in these bluish colors with larger and smaller ice drops, larger for the dark blue ice crystals, and the brighter the blue gets, or more to the greenish, it's for smaller ice crystals. And in the lower levels, something that you could not observe with the pure true color RGB, the lower levels here are these water clouds, humidity that is sucked into the tropical cyclone. And I was interested in the vertical profile. So if you have this cyclone, there must be a lot of convergence in the lower levels and probably also some divergence on the top. So let's have a look on the vertical profiles. And here you have 950 hectopascal. That's what you expect. The red isolines is the convergence, that you have a strong convergence of the air in the lower levels. And then I found a very strong divergence at 100 hectopascal. That's how it should be. That's what we expect. But what was interesting to see is if we move up a little bit only for 30 hectopascal, which is quite a lot because the air is not very dense there, but you see that the divergence disappears almost. And here we are probably above the tropopause. We have convergence again. And if we move down, so we had very strong divergence here. And if we move down below the strong divergence at 150 hectopascal, again we have convergence. And we will have convergence all along down to the ground, to the surface. You will always see convergence. Only in 100 hectopascal you will see a strong divergence. And that is what really surprised me a little bit. I thought that the area of divergence in the height would be much broader, but in fact it's a very thin layer of divergence, while the area of convergence is quite broad. So this is really nicely seen in this model fields. And now to finish, let's come to the topic of the day, let's say, because this was a very recent eruption in Somalia, a volcano that was sleeping for many, many years, thousands of years, and now has erupted suddenly without any warning. What you see here is the Dust RGB, and you may wonder why I don't take the ash RGB, which is tuned for volcanic eruptions. Well, sometimes the Dust RGB is a little bit better depicting the colors, and the recipe is very similar. It's exactly the same for the input channels. It's a little bit different for the thresholds. Obviously, this is our images that I got from colleagues and were disseminated in the internet. The Dust RGB shows them nicely. So there's ash and SO2 and some low-level dust or something in this direction. But can you point out, let's say, for example, the SO2, where would you see the SO2 cloud in this image? And I'll let you annotate again. Please annotate where you see the SO2 cloud. Make a, yes, okay. Any other idea? Well, it should be a little bit intuitive. If you think on sulfur, it has a yellowish color. So sulfur SO2 cloud is this here. This is the SO2 cloud. You have maybe some water here in this area. Here you have probably some dust. Since this is the dust RGB, you remember the pinkish color of dust, which is very similar. And here in the reddish color, you have the ash. Why is it separated? It's separated because the emission is in different heights. This is a very low level emission, and this is an emission in higher levels. We will see later in another slide at what levels you will find that. So you can also take, strangely, for most of you probably, the Airmass RGB for depicting the components that are ejected from this volcano. And here you must be careful because the colors are inverted. So reddish, now not ash, but SO2. Here in this area, I will annotate it. Here, this is ash here. And here, sorry, this is SO2 in red, and this is the ash. So the colors are inverted if you take the Airmass RGB. And you don't see at all the low-level dust because the Airmass RGB does not well depict the low-level clouds. Let's continue, and let's have a look here from thin satellite block, the height of the cloud. You see that it's blue, sometimes dark, and this refers to very high cloud tops between 16 and 20 kilometers. While here the lower cloud plume here, which consists probably of some dust that's due to the eruption, is well below 5 kilometers, 4 or 5 kilometers, but not much higher. Yeah. So if there is a lot of dust and smoke in the air, so sorry, wrong button. Okay. Have to continue. It will be probably dissipated over large parts of the globe. So this is a loop, and I will try to start a loop. You can already see a little bit here over, yeah, at the edge of the image, where the Airmass RGB shows the sulfur cloud appearing, and I will start the loop. And here you can see how that propagates over India and now reaches even China. So it's propagating with the winds over the whole globe. And this is because the cloud, the sulfur cloud and the ash cloud also are elevated into very high regions. So this is again, and this is my last loop. Here again, the dust RGB, and now you can see the eruption and the different colors of sulfur and ash. And I will start again the loop. It's a very nice color. They get thinner and thinner and dissipate. Yeah, I started again just to see how nicely, as long as the concentrations are high, how nicely this is visible in the imagery. So there was not much problems on the ground over Yemen and Oman, but I have read also in the internet and posted from colleagues that the air traffic was affected over India because of the dust of the ash clouds, but otherwise I have not heard of any bigger issues caused by this volcanic eruption. So thank you very much.